In this video lecture, I will discuss some additional problems of first order linear homogeneous recurrence relation. So let us take this example. Solve the recurrence relation an is equal to 7 an minus 1 for n greater than and equal to 1 and a2 is equal to 98. So let me write the first order recurrence relation. So first order recurrence relation will be in this form: an is equal to c an minus 1 plus fn, okay, for n greater than and equal to 1. So this is the first order recurrence relation, and if it is homogeneous, the function value fn will be 0 and the solution of the recurrence relation will be an will be c power n a 0 plus summation of from k is equal to 1 to n c power n minus k f k for n greater than and equal to 1. So we can see here the given relation an is equal to 7 an minus 1. We can rewrite the given relation can be rewritten as an plus 1 is equal to 7 an, okay, for n greater than and equal to 0. So this is for n greater than and equal to 1. So instead of writing it in terms of an and an minus 1, we can write it in terms of an plus 1 and the value of n will change, okay. So now the general solution, you can see here there is no function, so definitely this is homogeneous. So when the recurrence relation is homogeneous, the general solution of the first order recurrence relation will be c power n a0, okay. A0 is the initial condition and c is the constant coefficient. So this whole term, this function value will be 0, so this whole thing will be 0. So this will be the general solution of the first order linear homogeneous recurrence relation, okay. So now using this, okay, we can write the solution, the general solution of this homogeneous relation is an is equal to c power n, and what is c? The coefficient of an, so that is 7 power n, okay, into a0. So we don't know the value of a0, so let us say, okay, this is equation 1, okay, equation 1. Now we know the value of a2, right? We want the value of a0, we want a2. So in the given equation, if in equation from equation 1, if I say from equation 1, if I substitute n is equal to 2 here in equation 1, so I will get, okay, here in place of n I'll put 2. So a2 is equal to 7 power 2 into a0, and a2 we know it is given 98, okay. So 98 is given to us, 7 square is equal to 49, and a0. So from this we will tell, okay, 80 is equal to 98 by 49, so that is 2. So once we get the value of a0, we can substitute back the value of a0 in equation 1, and the general solution will be 7 power n into 2, okay, for n greater than and equal to 1. So this is the general solution of the given recurrence relation, and the given recurrence relation is homogeneous linear recurrence relation, okay. So hope this is clear. Now let us take one more example. Okay, here it is given, okay, if an n greater than and equal to 0 is the solution of an plus 1 minus kan, okay, and a3 is equal to 153 by 49, and a5, this value is given. What is the value of k? Okay, so I can, okay, rewrite the given equation an plus 1 minus kn is equal to 0. So we can rewrite it as an plus 1 is equal to kan right? And first order recurrence relation, okay, we know the recurrence relation is an is equal to can minus 1 plus fn. Since here also the function is 0, we are discussing only homogeneous one. So the solution, general solution of the first order linear homogeneous recurrence relation will be only c bar n a0, right? Now for this recurrence relation, this is for n greater than um, and equal to 1. So the general solution will be what? General solution will be an is equal to k par n a0. So an is what? C par n. So what is c? The coefficient of an. So the coefficient of an is k here. So k par n a0. So this is for n greater than or equal to 1. This we will say, okay, this is equation 1. And now we want to find the value of k. And this a3 value and a5 value is given. So what we'll do? We'll say, okay, from equation 1, if we substitute n as 3. So that means if I substitute n is equal to 3 here in this equation, this will be a3 is equal to k par 3 a0. Okay, that is equation 2 we will say. And same way in equation 1, if I substitute n as 5, okay, n as 5, because a3 and a5 is given. That's why we want to know the value, because a3 and a5 value is known to us. So using that we want to find the value of k. So if I substitute n as k here, n as 5 here in equation 1, it will be a5 n is 5, k power 5, okay, a0. That is equation 3. And from equation 2 and 3 we get, okay, from equation 2 and 3 we get a5 by a3 is equal to k square, okay, and k square will be what? a5 by a3. And what is a5? It is 1377 upon 2401. So it will be 1377 upon 2401 divided by a3 is 153 by 49. So it will be into 49 by 153. Okay. So when we solve this, we get k square is equal to, after solving this, we will get 9 by 49, and then therefore we will say k is equal to plus minus 3 by 7, and this will be the answer. This value we wanted the value of k only, so this will be the answer. So hope the concept is clear to you. Thank you for watching.